Hey guys, welcome back to the channel. Today we are going to solve Leetcode problem 977, squares of a sorted array. So let's dive in. So here's the problem. We are given an array of integers sorted in non-decreasing order, and our goal is to return a new array where we square each number, and the result is also sorted in non-decreasing order. The brute force approach would be to square all the numbers. So here we have 25, 4, 1, and 16. And then we can sort the result to be 1, 4, 16, and 25. The problem with this approach is that it would take O n log n time complexity, because sorting dominates the process. We can do better though and solve this in O(n) time by using a technique called two pointers. Let's break it down. The two pointers approach works here because the array is sorted. This means we will have negative values on the left side and positive values on the right. And to apply this technique, we start by placing one pointer, let's call it left, at the beginning of the array, and another pointer, let's call it right at the end. But before we get to the code, here's some points to keep in mind. When we square a negative number, it will always give us a positive result, because basically the square of -2 is -2 times -2. And because we have two minus, this will become plus, so we have a positive 4. Okay. And the second point to keep in mind is the larger the number, the larger its square. What this means is basically if we compare if the square of -5 is bigger than the square of 4, we don't necessarily need to calculate the square to know the result, because if 4 is bigger than 5, the square of 5 will also be bigger than the square of 4. So 25 is also bigger than 16. Okay. With these 2 points in mind, and knowing that the array is sorted, we can be sure that one of our pointers, left or right, will point to the largest number at the start. This allows us to view the result array from back to front, ensuring it's already sorted. So here is the result array. We'll start filling the values from here. What we need to do now is to compare the absolute value at both ends and add the square of the large one on the result array. So we will check if the absolute value of -5 is bigger than the absolute value of 4. If it is, in this case it is, we will calculate the square of 5 and place at the last position here. So 25. And now because the left value is the bigger one, we will move the left pointer to the next position. So we compare the values again. The absolute value of 2 is bigger than the absolute value of 4. It is not, so we will place the square of 4 in our answer. Okay, now we move the right pointer to the next value, do the same calculation. So the absolute value of 2 is bigger than the absolute value of 1. It is, so we add the square of 2 here, and we move the left pointer to the next value. Because the pointers are in the same position, we know it's the last value that we need to look at, and we can just place the square of 1 at the beginning of the result array. So the square of 1 is basically 1. Okay, so with this approach, we basically need to go through the array once. We'll go through the array comparing the values just to create the result already sorted. Let's take a look at the code to see how this works. So here at the code, we'll start with a variable getting the size of the array. We'll start the left pointer at the beginning, the right pointer at the last position, and we will create our answer here. Just fill it with zeros for now. And let's go through the array backwards. So basically we're gonna go in this direction. Okay, now what we need to do is basically compare if the absolute value from the left pointer is bigger than the absolute value from the right pointer. If it is, we want to get this value on the left, and we increase the left pointer to the next position. If it is not, so we want the value from the right position, and we will decrease the right pointer to move to the next position as well. And right now we can just put the square of the value in our answer, and we can return the answer here. Okay, let's see if that works. Okay, so as you can see, this approach works, and because we only need to go through the array once, we have time complex here of O(n), where the n is equals the size of the array, and the time complex here is also O(n), because we are creating a new array from the result. So our answer in this case, the length of answer will be equal to the length of n. That's it for today's problem. I hope this solution was clear and helpful. If you found it useful, don't forget to like and subscribe for more Leetcode problems. Thanks for watching, and I will see you in the next one.